Alright, welcome back to another episode on Additional Mathematics Syllabus Code number 4049, Chapter 11 of our textbooks. We are going to look at Chapter 11 of our textbooks once again, which is on differentiation, as I've mentioned in the previous video. And today, we will be looking at basic differentiation. Alright, so what comes to your mind when you hear this word basic differentiation? For me, right, you can pause the video to think about it and I'll review my answer shortly. But for me, right, what I know about basic differentiation is that I know you're going to differentiate something, of course, and maybe basic might be like basic terms. So let's unpack basic terms further. Alright, basic terms can be like numbers, alright, and maybe unknowns, alright. Unknowns can be packed further into maybe X, or yeah, just say X for now, alright. So these are some things that I think about when I see basic differentiation, and we will go into the steps to do basic differentiation. There are only 2 steps and it is very easy. Alright, so we are going to look at the steps to do basic differentiation or solve basic differentiation questions. Alright, 2 steps. So the first step, right, is you're gonna bring your power number down, or just write power number come down. Oh, 3 steps, by the way. Sorry about that. Second one, power number minus 1. And the third step is to ignore your whole numbers, alright, or we call it constants. Yeah. So these are the 3 steps when you are doing basic differentiation questions. And now we will look into questions on basic differentiation. Alright, so we'll look at something simple and then we will look at something more advanced. So there will be 3 exemplar questions. I'll write all 3. I'll write one by one, as I'll take a screenshot and upload it on my website. Okay. Alright, so this is the first exemplar question here, where we are going to differentiate the following with respect to x, where y is equals to 2x squared. Alright, so what kind of differentiation is this? It's a basic differentiation, isn't it? Alright, so of course you don't need to write it down, but I'm just writing it down to show you and get you to understand it better. And is it in a nice form to differentiate, meaning that there are no fractions. Alright, so these are the 2 questions I usually ask myself. Alright, so to solve differentiation questions, there are 2 strategies. And for trigo differentiation, I have already shared some strategies, and yeah, I'm going to elaborate more on the nice way to differentiate. So the first strategy when we are trying to solve differentiation question is which method do we use to solve it. So which method or which rule? I hope this will help you, as it is a method that I always use to solve differentiation questions. And the second one, ask yourself this question: is it in a nice way? Is it a nice way to dy dx? So what do I mean by nice way? As I have mentioned in trigo differentiation, nice way means no fractions. What do I mean by no fractions, right? So basically, what I mean that, because if let's say I have this number here, I want to change it into an index form. So if let's say we know that square root x is the same as x to the power of half, right? So, or let me make it simpler for you, no fractions or no third form. Alright, I forgot to write that. So we don't want to see any third form, alright? So if let's say I give you this, or I give you 3 square root x, we know that square root x is x to the power of half. I might want to change it into 3x to the power of half. Or maybe if I see this, I want to change it, yeah? And I will show you how to change this shortly. Alright, so we can change this into, let's say, 3x to the power of negative half. Why is it negative half? Unpack it for you further. 3 over x to the power of half. And because we know that half is at the denominator, we know that x to the power of minus 1, we can rewrite it as 1 over x. But this time, your 1 now is your 3. Alright, so I'll replace this into 3, and there'll be a 3 here, and your minus half, 1 become minus half. And you do notice that your x has a power 1 over here, and that's why you have an x to the power of half here. That's why it is 3x to the power of negative half. Alright, but just take note lah, for now, I just don't want to see any fractions or third form, and I will rather change into index form. Alright, but you might ask me, but here got fraction Don't worry, it's in index form, remember? This means that this whole term means that it is in index form. Alright, so when it's in index form, you don't have to worry. Just follow the methods. And if you want to use a calculator, press it into the calculator. And in your exams, you can use your calculators. So do not have to worry about it. Whenever you see your power having a fraction, it is okay. You are on the right track. Alright? So that is what I mean by no fractions, as I realized that I need to elaborate this because I did not really elaborate in trigo differentiation. I will elaborate it here so that you know how to do the differentiation questions easily. Alright, I'll take a screenshot of this and I will upload it onto my website. Alright, so let's continue on with this question here, where we are going to differentiate y is equals to 2x squared. So remember your basic differentiation rules, where you got power number come down. I'll just like go down, and then followed by power number minus 1. And then you will ignore constants or whole numbers. Alright, so these are the 3 steps here. So you will start by writing dy over dx. Alright, so I already elaborated on when do we write dy over dx, but I will elaborate it again here in this video. We only write dy over dx when we are differentiating, when we are changing the form, right? Let's say I give you this y equals to 3 square root x, and you tell me dy over dx is 3x power half. This is wrong. Why is it wrong? Because you are just rewriting it in another form. You are not differentiating. That's why I elaborate one more time again, ladies and gentlemen. When you write dy dx is when you are differentiating. So instead, you should write y equals to, I'll write it in green, y equals to 3x to the power of half, and then you dy over dx, which is blah 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 blah. Okay, so that's when you write your dy over dx. Okay, so let's start the question with dy over dx equals to power number go down, remember? So this is a 2 bracket 2, power number minus 1, 2 minus 1. We have done the first 2 steps. Do we have a constant or whole number here? Don't have. So that's your answer. It is just equals to 2 times 2 is 4. X to the power of 2 minus 1. This is the same as x to the power of 1, which is just x. So this is just 4x. Alright. So this is how I will solve this differentiation question. And the second question, let's make it a little bit more tougher. Yeah, of course, we have to all learn how to solve like hard questions in case it comes out in the exams, right? So let's begin with another tough question where we will involve let's say this question over here. Let me see, yeah. Got it. All right. Differentiate the following with respect to x. Y is equal to 3x squared plus 1 over 3x squared. All right. Remember, yeah. What kind of differentiation is this? This is a basic differentiation. Why is it basic differentiation? Because we just learned it today. All right. So let's start now. So ask yourself these two questions, yeah. What method? We already know the method. Is it a nice way to differentiate? Is it? Not yet, right? Let's change the form. How? So let's see. Y equals to 3x squared plus. All right. How are we gonna write this? All right. Remember. So remember about this rule where I write earlier x to the power of -1 is the same as 1 over x. But now I have 1 over 3x squared. Alright, so to make life easier for you, I will write the invisible 1 here as it's a 1x. Alright, so this is the same as 1 over 1. Alright, so actually I will write the 1 properly. Yep. And then we have an x to the power of 1 here. And you can see, and you can see that there's a -1 here as well. So how are you going to write it out, ladies and gentlemen? We are going to write it as 1 over 3x to the power of -2. Alright. So why is it like that? Because we just apply whatever we did here. And now your 1, now it becomes your 2 and your 2 here. Your 1 here becomes your 3 and your 3. Alright, so let's start by, and let's ask ourselves this question one more time. Is it now in a proper way or nice way to differentiate? Yes. And to elaborate, even though your power is negative here, you can still differentiate. Alright, remember? And let's start to differentiate. So dy over dx, which is first term first, power number go down, power number -1, 3 times 2, 6, right? X to the power of 2 minus 1 is just x to the power of 1, which is just x. Alright, and now we will add a plus sign. Alright, so now 1/3 times -2. Let's type it in our calculators. This is minus 2 over 3x to the power of power number -1, x to the power of -2 minus 1, x to the power of -3. Alright, so now can we leave our answer in negative index? For me, I will play safe. I will leave it in positive index. So it's 6x minus 2 over 3. When your power is negative, alright, this is a hack. Shift it down to the denominator, and this is your final answer. Alright, so this is how we solve the second question, and now we will do a slightly tougher one where we will include pi. Alright, okay, I will not show the steps, I mean, you want me to show, I can show lah. Sorry for the M. What's the M, bruh? Okay, so let's start by doing another question. This is interesting. Alright, differentiate the following with respect to x, where y is equals to pi, the whole thing bracket 11x squared minus 3x cubed. So when we see this, first thing, what method is it? This is a basic, yeah? So, remember, when I see this, right, how am I going to differentiate? So, I'll rewrite it and I will expand it in. Alright, so pi times 11x squared, this will give us 11 pi x squared. And then pi times minus 3x cubed, it will be a minus 3 pi x cubed. Alright, so is it a nice one to differentiate now? Yes. Alright, but one thing let me tell you, do not be scared of pi, as pi is just a constant. It is not an unknown. Your unknown this time is your x, not your pi. And if you type pi in the calculator, pi is equals to 3.141592. Furthermore, we can say that this is a whole number, which is a constant. Alright? So do not be scared when you see pi. Just continue to differentiate. You are on the right track. Do not worry. So let's start differentiating. dy over dx. Power number come down. 11 times 2. 22 pi. Alright, 11 pi times 2 is 22 pi. And x to the power of 2 minus 1 is just x. X to the power of 1 is just x. So minus 3 pi times 3, this is minus 9 pi. And then power number minus 1. So 3 minus 1 is just x squared. X to the power of 3 minus 1 is x squared. Alright, and do we have any constants here? Don't have. And that's it. It's our final answer. Alright, with that, I hope you understand what does basic differentiation mean, and all the differentiation techniques have all been uploaded onto the website, and I will upload this shortly. Alright. Oh, my fault.